Hello everybody. Today we are going to get started with the first step in hacking, that is information gathering. So we want to gather as much information as we can about the target, what operating system it is running, are there any ports open, what all services they are running, and are there any old services that we can exploit and other things. So we will boot up our Metasploitable machine as well as Kali Linux, and before that we will just take a snapshot of both of them to make sure that in case we do anything that harms the system, we can revert back. And also in the settings in network, make sure that the network adapter is enabled and they're attached to a NAT network so that the Metasploitable machine and the Kali Linux machine are on the same network and can communicate with each other. So we are going to log in with MSF admin as the username and password in Metasploitable. So that's done. And we are going to log in Kali Linux. And as you can see, the screen looks a little different, and so does the desktop background because Kali Linux has been recently upgraded. So this is the new background, and also the terminal has been changed from bash to ZSH. So your new terminal will look something like this. So this is the current working directory, the username, and the host name. But for now, I will just use bash because I like it more. And to upgrade to the latest version, you need to run a command that is sudo apt update, then two ampersands. So this is the second command, sudo apt upgrade. So what this does is that the apt is the package manager for Debian. So what it does is that it can be only run by root. So what it does is it checks on all repositories and makes a list of what all packages can be updated with this command. And what sudo apt upgrade does is all the packages which can be updated, it just upgrades them. So I've already run this command, and you should run this command at least once a week. And if it says when running the sudo command, if it says that ohm is not or the username is not in the sudoers file, which can be confirmed with ID. As you can see, I'm not in the sudo group. What we can do is su to Kali, that is the default username, and then we can do sudo user mod, which stands for modify user, and this will only work if the user is already added. So sudo user mod, then the username, which is ohm dash a for append, so that we want this group to be added to the already existing groups, dash capital G for the group name, and group name is sudo. Press enter, it will ask us for the password for Kali, which is Kali, and it should be done. So we can do exit, which will close the terminal, log out, and then just log in back again. So today what we are going to be doing is talking about IP addresses, ports, sockets. Then we are going to build a Python script which scans for open ports, and then we are going to learn how to use Nmap. I'm going to be using Python for this video series. If you want, you can follow along with Python or your favorite programming language. And it will be helpful if you know at least one programming language, and Python is used mostly because it has many packages available which can be readily imported. So as you can see that now I'm in the sudo group also. I'm just going to cd into desktop, and then we are going to talk about IP addresses. So in a network, what IP address does is that it identifies a device uniquely. For example, let's say I have an IP address of 10 and the other device has an IP address of 9. In IP addresses are usually of type number dot number dot number dot number, which you can see if you do ifconfig with sudo, it will ask us for password. So this is the IP address in IPv4 format and this in IPv6. that is the version 6, newer version, and this is the older version. And I've seen mostly that this is used. So we've got 10.0.2.15. This IP address will identify uniquely this device on the network. So no other device on this network can have the same IP address. And now this IP address is only for the local area network, which if you go click on this button, which will show all the networks, it shows as the wired connection 1, which is if you plug in the Ethernet cable. Similarly, if we go over to Metasploitable, we can do ifconfig and it will show the IP address, which is 10.0.2.6, and here it's 10.0.2.15. So whenever we are hacking a device, we need to know at least the IP address to begin with. So we can try to ping that device. So what ping does is that it will send some specially crafted data to that device or that IP address, and that device responds back if it is up and running. In some cases, this ping is blocked and we won't be able to know if it is up and running, but most of the time for servers and other devices it is up and running. So we can just do ping, which is a binary in the bin folder, and then the IP address, which will ping our own device, since 10.0.2.15 is our device, and I stopped this with Control C. Similarly, we can ping the metasploitable machine. So we'll go to our terminal, ping 10.0.2.6, and I am not able to ping this machine. So looks like there is some problem. The host is unreachable. So I'm just going to debug this and be right back. Okay, so the problem was that I was not connected to the NAT network, which is what I just told you. So now I'm connected to the NAT network and I will be able to ping this. So now both the Kali Linux machine and the Metasploitable machine are on the same network. Okay, so that was about IP addresses. And we can just do echo 10.0.2.6, that is our IP, and we can write this to a file. So now we have a file on our desktop named IP, as you can see. I'll just make a directory for Metasploitable. I hope I spelled it correctly. Metasploitable. CD into that, and then we can use the move command to move that IP file into the current directory. Okay, and now we are going to build a Python script to look for open ports and services. So let's first talk about ports or sockets. So what are sockets? Sockets are ports on the network. Just like we have USB ports where one port can fit into another and the two can communicate. Similarly, we have ports in networking where one device has a software port, another device has another software port. One is in the listen mode, similar to our laptop's USB port, and another socket port connects to it. In the same manner like we plug in a USB device into the USB port. Similarly, a socket is listening and one another socket comes and connect to it. Sockets are basis of network. So whenever you visit a website, Google, my website, Creative Robotics, any website, any file server, it will use sockets. Okay, so let's go to google.com from our web browser. So you can open up the web browser, which is Mozilla Firefox, by clicking on this button. It's going to take a minute, and let's go to google.com. So what does it do behind the screen? So what it does is that it asks Kali Linux to give it a socket. What Mozilla does is that it asks Kali Linux for a free socket so that it can connect to the required site. Then it finds the IP address of Google, which we will talk about when we start web exploitation. Then it finds the IP address of Google and it connects to port 80 because we have not specified any port. In web browsers, we can specify a port with colon. So after the colon, we can have some random number with the port we want to connect to. By default, web servers are on port 80. And in all, we have about 65,535 ports. And we are going to build a Python script which we will call scan.py. Uh, the .py extension is for Python script, which scans all the 65,535 something ports and then displays to us which all ports are open so that we can find if there is a web server, a file server, or whatever else is running. So scripts in Linux begin with a shebang, which is this comment sign, that is the hash, and then we have an exclamation mark, and then we do user bin n. This is an executable file on Linux, which will just search for the specified interpreter, which in our case is Python 3. Okay, so we are just going to add a print statement, initialized, just to know that it is working. Control X to save, Y, and then enter. We can do ls, there's scan.py. Then we are going to use another command which is chmod, which stands for change mode. So what it does is that let's do ls-l on scan.py. It will show the permissions for this. It says that it's not a directory and we can read it, write it, but not execute it. We do not have the executable permission. So what we can do is change mode, chmod plus x. We want to add executable permissions to scan.py, and then we can execute it like this. So the period or dot refers to current directory, slash inside the current directory scan.py. So we can confirm that this is working. Clear. You can also clear by Control Shift X or Control L. Control L works on most Linux distributions, and we can just start editing this. So we need to use sockets. So to use sockets, we will use the import statement with import socket. So now we can use sockets in our program. So we are saying sock is equal to socket.socket. So socket.socket, what this will do is it will ask the operating system, that is Kali Linux, to give us a socket which we can use to connect to other devices, and we are going to store it in the sock variable. Now socket, we need to specify some additional arguments, is that we require a TCP socket and some other details. So it's, I think, socket.af and socket, what I'm typing, socket.sockstring. Okay, and we are just going to run this to make sure there is no error and it's all good. So what we did was we asked the operating system to provide us a socket with these specifications. So we asked it to provide us a TCP socket. Now there are two protocols used in networking. One is TCP and one is UDP. So for this video, we will be only focusing on TCP ports, but we will also learn how to scan UDP ports with Nmap. So now we have a socket. We can connect using sock.connect to any IP address. Okay, so what we are going to do is use a for loop for port in range. We have a range of 65,535. So what this will do is that for every port which is in the range of 0 to 65,535, let's make that 1, 65,535, we are just going to tell it to print port without that. And we are just going to delete this initialize statement. So this should print every port between 0 and 65,535. So we do not want it only to print this, we want it to connect. So we are going to do socket.connect, and this is going to be in brackets because this is a function, and then we are going to pass it a tuple which is going to be inside these brackets. What is a tuple? It's a data type in Python. So now we can pass it the IP address which was 10.0.2.6, comma the port. So port is in this variable, and we are going to put this in a try block. So what it will do is that it will uh, make sure that no exception occurs. If an exception occurs, it will jump to the except block. So except keyboard interrupt. So what if we want to stop the program and press Ctrl C? Then it should do is what it should do is that it should exit the program if there's a keyboard interrupt, if we interrupt the program. But if there's any other error, that means the port is not open, it should just ignore that exception. And if this sock.connect command executes successfully, that means the port is open. If it does not execute successfully, it means that either we interrupted the execution or it encountered some other error. Okay, so if the execution was successful, that means we can connect to that port. So what we are going to do is print the port is open, and we are going to specify which port is open. This port is open. Okay, and we are going to now run this. Nothing happened. Okay, so what I did was wrong was I forgot that we did not name the variable socket, we named it sock. So this is the final code and we are going to test this. I just forget variable names and we see that port 21 is open. But what happened to other ports? Because Metasploitable is a machine that is meant to be exploited. So many more ports should be open. What we are going to do, what we are going to do is take this line and instead of it being over here, I pressed Ctrl key for cut. Instead of it being here, we are going to keep it over here, and that was Ctrl U for paste, Ctrl X, Y, scan.py, and we see that all these ports are open because a socket can only connect once unless we close that. So we see port 21 open, port 22 open, and it's scanning for all these ports. So we have port 21 open, 22 open, 23, 53, 80. So port 80 is open, which means that it's a web server, since web servers are generally hosted on port 80. So we can take a look on the web server by opening up a browser which is Mozilla, and we can go to 10.0.2.6 and we have this page. This is a HTML page. So we know that port 80 is open and we got so many services open. So that was how you can build a simple Python script to do that for us. And Control C to kill that. So this is the complete Python script which just connects to each port once and determines if it's open or closed. Okay, and this can be further improved using threading or something. So an improved version of this is the tool called Nmap. Nmap does the same thing, only it works on a very lower level and provides us plethora of information other than what we can only determine with a Python script whether a port is open or not. Nmap can do a lot more. It can determine versions, what all services are running, ports open, the versions of that service is running, what operating system is running on the target. It can even identify it. It goes on a very lower level to do all these things. So we can just do nmap and specify the IP address, which is the simplest form of using this. So it will scan for only 1000 ports, which are the most common 1000 ports. So it provides us some information, it hosts up, then latency, and then we've got so many ports open in a printed in a neat manner. So we've got the port, the protocol, which is either TCP or UDP, stayed open because it's not showing the closed ports, similar to our Python script. Sometimes you might open that closed or filtered ports show up, which is usually not the case with Nmap, and then it has even determined what version is running. So we've got FTP, which stands for File Transfer Protocol, which is for file servers. Then we've got SSH, which is used for remotely logging in. Similarly, we've got Telnet. Telnet is just like SSH, but it's not secure. It's an insecure protocol which was used for logging in. Then we've got HTTP, the Hypertext Transfer Protocol for port 80. As I showed you, we can connect to port 80 on the web server, and it's also determined all the services running. So how does Nmap do what it does? For the explanation, I'm just going to open up Nano. And let's say we have a client. I can't type. We have a client and we have a server. So what our Python script did was it used the TCP three-way handshake. Whenever a connection happens over TCP, this TCP three-way handshake takes place. So what is that? The client sends a SYN request to the server, okay, which just means that I want to connect to you at this port. Then what happens is that the server sends back a response which is either SYN ACK or it can be RST, which stands for reset. And I'm just going to put this symbol for OR. So if we send a SYN and it responds with a SYNAC, that means I want to connect to you at this port, and SYNAC response means that okay, I am ready, this port is open, please connect, because it is meant to serve that purpose. Suppose if Google or at port 80 responded with please don't connect, then we won't be able to search anything on Google. That is why these responds with SYNAC. But on the other hand, day-to-day laptops do not host any website. So these respond with RST since we do not want anyone to connect to our port 80. So that's what happens when we send an RST that we are rejecting. We do not want you to connect. And when we send a SYNAC, please connect to us. And then we respond back with a SYN, which means okay, thank you. Now I'm going to connect to you, or okay, I acknowledge that I will not connect to you. But instead of sending a SYN at the end, we could even send an RST, that is the reset, the same reset that the server can send to us. So what this will do is if we send a SYN request, the server responds with a SYNAC, that means the port is open. So if we respond with the RST saying that we do not want to connect, then we are not connecting to it, but we know that the port is open. The first case, that is like a Python script, we send a SYN request, we receive a SYNAC or an RST back. If we receive an RST, that means the connection failed and the port is closed, then we know that the port is closed. And if we receive a SYNAC back, that means the connection can be completed, and we always send back a SYN request, SYN packet with the socket library. This all of this the socket library handles for us. So this for Nmap is called the connect scan. So we are connecting to it. Now connections can be logged. So what happens is if you connect to a service at a certain port and the connection is successful, then that service might log into a file or somewhere that this IP address has connected to this port. And suppose we've got 1000 ports logging this information, and if we go and connect to all of these ports one at a time, then if someone is watching that file or the program is watching that file, it might arouse suspicion that why is the same IP address connecting over and over again to all different ports. So what Nmap does to reduce this logging and to make it anonymous is it sends a SYN request, and depending on the packet sent, it says whether it is open or not. If we receive a SYNAC, it says that yes, it is open, and if we receive an RST, it says okay, it's closed. But instead of sending back a SYN request, what we send back is an RST packet. So we tell it, Okay, I want to connect to you. It responds whether it is open or not open, and then we tell it, okay, I changed my mind, I do not want to connect to you. That is what the RST implies. So that in Nmap is called stealth scan. Okay, so that in Nmap is called stealth scan, which is only which can only be run with root privileges. So if you need a stealth scan or if you need operating system detection, you need to use it with sudo. So that was a bit about the TCP three-way handshake, and then we can use the man command to look at the manual for Nmap. So Nmap is a network mapper, which is an open source tool, and then it's got a lot of information, and we can look at these examples and all the options available. So some interesting ones are we'll just not look at the man page for now. We'll just do nmap dash dash help, and this will show us all the interesting options. So we've got dash capital PN, which is if we are not able to ping an IP address, but we know that it is online, it is discoverable on a network, we can supply a dash capital PN to make is because Nmap also pings that IP address before scanning for it. It just needs to make sure that the IP address we supplied is available on the network. So we can bypass that with using dash PN. By default, it scans for TCP. We can make it scan for UDP with dash S capital U. Then we have a dash P for port range. Now, as you saw when we did with the Python script, we scanned for these 65,535 ports. But when we do not specify any port range to Nmap, it scans for the 1000 top common ports. So we generally specify a dash P dash to scan for all ports. Then we have a dash SV. What it does is that it connects to all those ports and determines all the service and version info. Okay, so it will get us all the version information and some other information which it can receive from those sockets. And then there is another component of Nmap which is called the Nmap scripting engine. So it has some scripts for web servers, file servers, etc., which we can use by specifying dash sc, which is the equivalent of dash dash script equal to default. So it's going to find open ports and run these scripts against them for finding some more information. Then we have a dash capital O to enable operating system detection. So Nmap, as I said, is capable of even detecting the operating system. And then we've got all these options for evasion of firewalls and other things. And then we have a dash small o and for output. So it can output in normal, XML and many other formats, but we use dash on to output in normal, dash ox for XML and other formats for OS, OG and dash OA. What it does is outputs on all three major formats. We are going to be using dash on today. And then we have a dash capital A, which is equivalent of enabling OS detection, version detection, script scanning, and trace route. So it in dash A does uh, is the equivalent of dash capital O, dash SV, dash SC, and then trace route. So we can use Nmap now. Nmap 10.0.2.6, which is the IP address, and before that we can specify some more options, and we need to run these options with sudo because operating system detection and other things require sudo. So we are going to add in a dash sv because we want the version information, dash sc which is equivalent of scripts equal to default because we want as much information as we can, dash capital O to enable operating system detection, dash small o capital N to output in the normal format, and I'm going to call this nmap.scan, then a dash p dash which means all ports, and a dash T. Dash T stands for speed, and speed we can specify between 0 to 5, the higher being the faster, and with uh, as we increase the speed, Nmap might return less and less results or inaccurate results. So we are going to use dash T4 because we are not too worried about the results because this is just practice. So sudo will make sure that Nmap uses the stealth scan, dash SV for version detection, dash SC for scripts equal to default, dash capital O for OS detection, dash ON to output in Nmap format. Then we have the file name. So it will make a file called nmap.scan, dash P dash to scan for all ports, dash capital D4 for a higher speed. Then we have the IP address and we are also going to put a dash V. Dash V puts Nmap in verbose mode. So it will find information as soon as it finds information, it will print to the screen. And sudo will require the password. As you can see, it's printing ports as it finds them. And if for a long time Nmap stops printing something, then to for printing the current status, we can press the tab key or the up arrow key, which will print the stats, that is how many seconds elapsed, how many hosts completed, because Nmap is capable of even reading hosts from a file, that is the target IP addresses, and then scanning all of them. And we can see that one IP address is undergoing a SYN stealth scan, which I just explained to you about how much percent done and estimated time to complete and time remaining for the stealth scan. Then it's going to initiate the Nmap scripting engine and other things. So we've got so many ports open as you can see, and it said that we have completed the scan and we are going to initiate the service scan now. So I'm just going to wait for this to complete. It might take a while. 3 seconds remaining. So Nmap it's pretty fast. It does all the job in about 2 minutes. Okay, so the service scan finished. Complete service scan completed. Then we have initiated operating system detection. Then we have completed this. And so let's look at the results. And that's a lot of information it was able to find. So FTP, which is the file transfer protocol, it found out the version which is VFTPD 2.3.4. Then it found out that anonymous login for the file server is allowed, which should not be allowed. Then we've got the server status. We can log in. Then we've got SSH. We've got the SSH version, Open SSH version for Debian, which I think it is running Debian, the Metasploitable machine. Then we've got uh, Telnet. We've got all these versions also. We've got a lot of things. Okay, so we've even got information about that web server that it's running Apache, the version also, and it indicates that the machine is Ubuntu. It has the server header and the title, which is Metasploitable 2. Then it's got information about many other things. It's got information about all of this, NFS and SMB. Then it's got information about MySQL, another FTP port, which is Pro FTPD 1.3.1. So we've got the PostgreSQL database, we've got the version, so we've got a lot of things. Okay, we have even got the operating system. So it's running Linux.2.6.x. So it's 2.6 dot something else. It is guessing that it's between 2.6.9 and 2.6.33, and it's a Linux kernel. It's got the MAC address, which is the Oracle VirtualBox virtual MAC address, because this is a virtual machine, and this is pretty close. Okay, this Linux version. Let's just go to Metasploitable and do uname dash a. So this will give us the information about the machine, and we can see that it is Linux Metasploitable 2.6.24. Okay, and it's pretty close. It's in between that range. and that is how accurate Nmap can be. Sometimes it will say that it could not find a host with that fingerprint, but most of the time it is able to find that operating system. And we told Nmap to output in the normal format. We can do ls and we have got that file nmap.scan. We can use another command wc nmap.scan, which just gives us the word count, so we can see that we've got some content, and we can view that in interactive mode with the less command, less nmap.scan, and then we can just scroll up and down. So this is in an interactive mode. We can read this, and we've got all that information stored in this file. If we forget something or want to look at something again, we can just come back to this file. So there were a lot of ports open, and today we saw how we can scan for all these ports and how we can make our own scripts to do that. So that was all for today. In the next videos, we are going to see how we can exploit all these machines, all these services running, and gain access to that machine. Thank you for watching. I will see you next time.